All right, for the next group of questions, so these are situations where we're also approaching infinity or negative infinity, right? And so we're dealing with end behavior again, and this time we have rational expressions, right? We have a situation where we have a polynomial on top and a polynomial on bottom, right? And they all look a little different, but have that same thing. We have a variable expression on top, variable expression on the bottom. So I'm actually going to start with number 4 because I've identified here that the denominator degree is larger than the numerator degree, right? If that happens, remember, if let me write another graphic up here. All right, so here's our kind of little table here. So if we're given a situation like this where we have a polynomial on top, right, where a is the leading coefficient on top and m is the degree, and then we have a polynomial on the bottom where b is the leading coefficient and n is the degree, then we can evaluate if m is less than n or equal to or greater than n, right? If the top degree is larger than or is less than, equal than, or larger than the denominator degree, then we have these different scenarios, right? So if in this, like in number 4 here, if the numerator degree, which is 1 in this case, is less than the denominator degree, which is 2 in this case, then that means you're just going to get 0, right? So that's the easiest one. The next easiest one is one like number 5, where our degrees match up, right? The degrees are the same, like in the second case, and in that case, our limit's going to equal a over b, right? The coefficients, the ratio of the coefficients. So don't forget that negative in front, but it's just going to be negative 8 over 6, which we can reduce to negative 4 over 3. Okay, and that's our final answer. Okay, so that's how we do those, and just show work on those. You can do a couple things. You could circle the degrees, kind of show me that you understand that situation, or you can show kind of the basis of why this works, which is basically what we're doing is we're dividing every term by the largest variable exponent combination in the denominator. Okay, so in this case we'd be dividing by s to the 4th, everything by s to the 4th on top and bottom. Here we'd be dividing everything by t squared, right? Because that's the largest exponent combo in the denominator. Okay, so now, and that leads us to the number 3. So number 3 is the one where we have a little more work. So here m is greater than n, right? So 5 is greater than 2, and so we're going to get positive or negative infinity. We just have to figure out which one it is, and basically go back to how we did 1 and 2. So we're going to first divide everything by the largest variable and exponent in the denominator, right? So that'd be t squared, and so what we'll get is t to the 5th. Oh, oops, sorry about that. Let me see. T to the 5th over t squared on top, and then the bottom will have 3t squared over t squared plus 1 over t squared, right? And the limit as t approaches infinity, what will happen is these will go away, right? Cancel each other out. This will go to 0, okay? And then this will reduce to t to the 3rd. To 3 right there, okay? All right, and let me do a better job with that 3. All right, so and so if I rewrite this, it'll be the limit as t approaches infinity of t to the 3rd on top, and then on the bottom this went to 0, and so really all we have left on the bottom is that 3, because these canceled out. And so now basically another way to write that is 1/3 t cubed, right? So our leading coefficient is positive 1/3, our exponent is odd, And so that's going to be up on the right, down on the left, and here we're going to the right. And so it's going to be positive infinity, right? Okay. And so that's how we would do these ones. So first, evaluate the degrees in the numerator and denominator, and that can lead you to kind of the two, pretty straightforward answers. And or if m is greater than n, if the numerator degree is larger, then you have to do a little bit of work, dividing by x to the n power on, whatever the highest degree is on the bottom, and then evaluating the leading coefficient and the degree after that. Okay. All right. And that's how you can show work on those. And I want to point out one thing too, just to remember that, like for any of these, it doesn't matter whether you go to positive infinity or negative infinity. It doesn't matter where you go to the left or right. It does in this case ultimately, but these, situations hold no matter if you're going to positive or negative infinity. Okay. And then when you get, into the problem like number 3, then you have to evaluate if you're going left or right once you get to kind of this point here. Okay. All right. Let me know if you have any questions on these.